Hello, this is Mr. Pruitt, and today I'm talking about standing waves. This is part 3 in a series on basic wave behaviors and properties. So, what is a standing wave? Well, a standing wave is just a vibration in a system in which some points remain fixed and others between them vibrate at maximum amplitude. If you look at the picture over here, you'll see that there are some points in the wave that are always in the same spot along the midline, and then you will notice that there are points where everything is as far apart or at maximum amplitude from each other as they can get. So how are standing waves formed? Well, standing waves are formed or produced when pulses of equal magnitude and amplitude move in opposite directions through the same medium. So let's say that I've got a rope that's attached to the doorknob, and I send a pulse down that rope. When I send that pulse down, it travels down as a crest, and when it hits the doorknob, when it hits that boundary medium, the door, it's reflected back in the rope, but this time when it's reflected back, it becomes a trough, a reflected trough that's traveling in the opposite direction. Now, if I were to produce another pulse at the exact moment that we reflect that trough, we could create a standing wave because we would have these two equal magnitude pulses, and they are traveling at the same speed, opposite each other down the rope. Now, what that's going to do is it's going to form areas where they interact with each other, either as a constructive or a destructive interference. When that incident crest meets up with that reflected trough, we get an area of destructive interference, like we would see here, where the waves cross. And when a reflected crest and a incident crest meet up, we would have these points where the crests actually build up and become larger, and those are those points where we would have maximum amplitude. Now, because of this, we only get standing waves when we're at particular frequencies, because you have to have them in phase with each other, or the frequency has to match up. Where basically I might have 6 waves passing per second going toward the door, I would also need 6 waves per second coming back toward the door from the door, reflected back, to form this standing wave. So a couple of features that you need to be familiar with on this are what we call nodes. Nodes are formed when the incident crest and the reflected trough undergo destructive interference, and that's each of these places where you see the black dot. Those are places where those waves, because they're undergoing destructive interference, they're canceling the wave out. If this were a sound wave, at the nodes, we wouldn't be able to actually hear a sound because their energy would be canceling each other out at that point. The other big feature you need to know about is what they call an antinode. Antinodes are formed when the incident crest and the reflected crest, or the incident trough and the reflected trough, undergo constructive interference, basically that they build the wave up. And so when that occurs, we get maximum amplitude on the wave. It gets bigger. It's as loud as it's going to get. It has the most energy it's going to have. So let's practice for just a second and figure out how many nodes and antinodes are here. So the first question here says, how many nodes does the standing wave exhibit? Well, when we're looking for this, what we're really looking for is the number of places that our waves cross at the midline. So we have 1 here. So 1, 2, 3, 4, 5. So we would say that we have 5 nodes. Now, if we wanted to know how many antinodes it has, we would find the highest point, or these points where there's maximum amplitude between the crest and the trough, maximum distance, and we would count those. So in this case, we have 1, 2, 3, 4 antinodes.
Today, you must have a wristband on. Those wristbands.
So how many nodes does the standing wave exhibit? 5 nodes. How many antinodes does the standing wave exhibit? 4 antinodes.
Get your wristband. If you have jeans on today, $1 to wear.
Thank you.